In this video, I'm going to provide you with a solution to the question that is seen. Please know that you may not see this question in its entirety during the steps of answering each of the 4 questions that are asked. Alright? We have 2 triangles. We have NBP and we have BPQ. Good? We are using the information given as much as we can to answer these questions. And in all cases, we are going to round our answer to the nearest whole number. Our first part asks us to find the angle PBQ. PBQ. When you are given 3 letters, the one that is in the middle, in this case it is B, that is the one we want to find. And notice we were given some information here that we can use. We know that for both triangles, they will add up to 47 degrees. And we know that one of those angles, this is the angle of both of them. One of them is 33. So if we know that both must add up to 47, then we can find the remaining by subtracting 33 from 47 to find this piece that we do not know. We do not know this piece of it. Good? So all you do for step A is to subtract 33 from 47 degrees. 33 from 47 leaves us with 14. So this piece will be 14. And of course, do not look at the way that it is drawn and say that, well, this part is smaller than this part. It is never drawn to scale. Never drawn to scale. Good? So we've completed part A. Let us look at part B. We want to find the distance PQ. 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 We do not know PQ. But there's some things that we do know that can help us. Look and look here carefully. I am going to do a rough sketch of what is seen. This is my B. Come across. And then I go across here. This is my rough sketch. I'm going to take it away from this compound triangle and make it a simple one. So I have my B. I know that this angle measures 14 degrees. This side, which is BQ, it measures 150 km. And this side, BP, is 80 km. Good? So this is what I'm going to look at. Students, you need to find a way to simplify whatever you see on your exam. Never allow anything to confuse you. You are going to see more than what you need for a certain part in a question. It's okay to take it out, right? So that you can see a simplified form of what you want to work with. Now, you won't be given points for this. I have just done it for those visual learners. You want to see it, then this is what you do. Now, to answer this question, part B, we will have to go through a series of steps. Yes. And we will have to use what is called there are 2 rules. We have the sine rule and the cosine rule. We have to look to see which rule is applicable in this case. Both are not applicable. They are not applicable. Only one of them is applicable. All right? And the one that is applicable is the cosine rule. Now, why? Are we going to guess? No. Now, in trigonometry, there are only two rules. Sine rule, cosine rule. Each of them has conditions. What I will say to persons, instead of trying to remember the conditions for both, remember the conditions for one of them. Because if you remember the condition for one and it is not applicable to that one, then obviously you use the other rule, because there is no tangent rule. We just have our sine rule and our cosine rule. And look why I say the cosine rule is applicable in this case. It is used under two conditions. When we have the length of two sides and an included angle. The length of two sides and an included angle. Included means that the angle falls between the two sides. Now, say for instance, that wasn't the given angle. The given angle was up here. This was our 14 degrees. It is not included, because if the angle was up here, then it means that we should have known this angle, and so it would have been included in this case. So no, right? The angle has to fall in between. That's one of the conditions. There is one more condition for the cosine rule. So since I said that one to you, let me also say to you that we prove it for an acute triangle. The other rule is that we have to know all three sides. We must know the length of all three sides. And in this case, we don't. We know the length of two and an included angle. So here we go. PQ, P, the length PQ. So we do not know PQ, we want to find what PQ is. In order for us to use one of the cosine rules, and the one that is applicable in this case, so this will be my small p. The one that is applicable in this case, my PQ, I'm going to use it as little b. Let PQ be equal to common b. So my rule will say b squared. I am going to use the sides. I'm going to use this side as little a, and I'm going to use this side as my little b. Okay, I have A, B, C. Right, so this will be my B, that's my A, and that's my C. All right, so here I go. B squared is equal to A squared plus C squared minus 2AC cos of B. You will be given the formula as well. Do not worry about memorizing it, and then you do not get it correctly. All right, so my unknown is my PQ, right? And I have used letter B to represent my unknown. Good, so I'm going to substitute now. A, small a, is represented by 80 km square. Little c is represented by the length of little c is 150 km. And we want to subtract 2 times A times C. And we want to also multiply that by cos of the angle B. Good. So we have a number of things we're looking at here. 80 multiplied by 80, 6,400. 150 multiplied by 150, 500 km square. Then we want to subtract all of this, but I'm going to do 2 times 80, 160 times 150. cos 14 good. And another thing, where possible, when you have more than 4 decimal places for your angle, once you complete your angle in your calculator and you have a number of digits there more than 4, take it to the nearest 4 decimal place. 4 decimal places. Good. When we add these two together now, so that gives me that, and I need to do cos of this. Alright. So my next stage will give me 2,5, that's my b square. My next step is to square root both sides because I need an answer for b. I do not need an answer for b square. So you square root both sides to get rid of the square. The square goes with the square root. 1 second. We will have 74.919, and our instruction told us to round it to the nearest whole number. So we have 75 km. Alright? So we've completed parts A and B. Review the solution. Look at the steps. Take your calculators. Perform the exact same operations I have performed and prove it for yourselves. Alright? I am moving to part C. The obtuse angle BPQ. BPQ. Remember I told you it's the center, the letter that is in the middle. So now, look at this. This is the one I want. We just found little b. Little b is now our little b is now 75 km, right? And we want to find angle P because it says to us BPQ. Angle P. Let me get another sheet of paper. Good. So in this case, I can use a certain rule. I am going to use the sine rule in this case. All right? I can use it when I know two sides and an angle, but I must not know an included angle. All right? So when I know two angles and the length of one side, or I know two sides and the length of one angle, and the degrees of one angle, I can use the sine rule. And so using the sine rule in this case, BPQ. Using the sine rule in this case, and remember what it says to us, small a over large A is equal to small b over, they call it big B, but the numerator represents the side. The denominator represents the angle, right? And then they have small c over big C. But at no given point do we use all three. We only use two. And then another thing that we need to note is that sometimes we do not have A, B, and C. But in a number of cases, they will try to give us 3 consecutive letters. All right? So we are going to substitute for 2 of them. 150 over our large P. Uh, 75. Remember, this is my small b and my big B. So I know the side, which goes as the numerator, and I know the angle, which goes as the denominator. And our first one was, we had known the side, but we do not know the angle. The angle goes with opposite side. The angle goes with the opposite side. That's how I form these two. And we can say we cross multiply. Right? I want sin P by itself, so I'm going to get rid of 75 km so that these two will cancel themselves and I will have sin P standing on its own. All right, 150 times I'm going to do sin 14 times 150, and I'm going to get 36.2883. I'm dividing that by 75 km. .4838. Good. Now I cannot leave my answer like this. When we are solving to find the length of an angle, we have to inverse. And this is the length of an angle we're solving to find. Remember, it was angle P. Remember, the obtuse angle P. Well, so I have to inverse. So I can say P is equal to sin inverse of 0.4838. Therefore, P is equal to the nearest degrees is equal to this. Yeah. If you are confused, you believe you have doubts, pause the video, review, look at additional resources. You do what is necessary. You may also ask me to provide you with additional examples, and I will do so as soon as possible. So now I know that this angle is 29 degrees. Good. So my part D is for the bearing of Q from P. Q from P. And here we go. It's just one operation we need to perform. Q from P. Right? These are the two we're looking at. And remember, angles on a straight line add up to 180. Angles on a... And this wasn't even my obtuse angle. My obtuse angle, this one was incomplete. This one is my little p, which is the acute angle. So my obtuse angle would have been, in this case, 180 minus 29. Angles on a straight line add up to 180. 180 minus that, 151. Yeah. I noticed my error early, so I'm able to. Good. Notice what it says here, obtuse. And 29 is not an obtuse. 29 is an acute angle. Good? 29 would be an acute angle. So my obtuse angle will be 29 from 180, as in this case. Good? So I have to find that angle first, and then... So therefore, we can say that P is exactly 151 degrees. And the last part, any triangle would add up to 180 degrees. And right? And we have two triangles, and we put them together. So we're going to work on our bearings now. All right? This will be our third part, our bearings. Hang on. I am going to bring that to you in my following video, but look carefully. It was our obtuse angle we wanted. 29 was the acute. Straight angles add up to 180. Angles on a straight line add up to 180, so we have to subtract it from 180. Good? Thank you.